Hello everyone. Welcome to the solution of LeetCode problem 41 named first missing positive. In this problem, we are given an unsorted integer array and we have to return the smallest positive integer that is not presented in the given array. And we must implement an algorithm that runs in big O of n runtime and use big O of 1 auxiliary space. Now, in the first example, the array contains 3 elements, which is 0, 1, and 2. So, the first positive integer that is missing is 3 here. So, in this problem, we have to return 3. Now, for this example, the array has 3, 4, minus 1, and 1. So, here the element 2 is missing. So, here we have to return 2. Similarly, in this last example, the array has 5 elements, which is 7, 8, 9, 11, and 12. So here the smallest positive integer which is missing is 1. So in this problem, we have to return 1. Now, the array length can be in between 1 to 10 to the power 5. And each of the array elements can be in between minus 2 to the power 31 to positive 2 to the power 31 minus 1. I hope you understood the problem statement. Now let's move on to the algorithm. Now, to understand the algorithm clearly, we have taken another example. Now, suppose our current array is this, which is 0, 1, 7, 7, 2, 3, 4, 5, minus 2, and minus 9. Now, the index number of this will be starting from 0 and end here from 9. So here the index number will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. Now, this is our original array. So each time we will manipulate the original array respectively. Now, in the first operation, we have to replace all of the negative integers and all of the 0 and all of the integers which is greater than the array size with 1. So now we have to replace 0 with 1. The 1 will remain same. Then the 7, 7, 2, 3, 4, 5, and there is minus 2. So it is negative. So we have to replace it with 1. There is minus 9, which is also negative. We have to replace it with 1. Now, we have to iterate this array from left to right. And each time, we will replace the corresponding index with negative number. Suppose currently we are at this position, which is 1. So here we have to replace the element which is presented at 1 index with negative sign. So we will make it negative. Now we are at these positions. It has minus 1. So absolute value of minus 1 will be 1. So we have to replace the element which present in the 1 index with minus 1. So it is already negative here. So we don't have to do anything right now. Now we are at this element 7. So we have to replace the element which is presented at 7th index with negative. So it will become minus 5. Now we are again at the 7th. So we have to replace the element which is present in the 7th index with negative, but it is still minus 5. So we don't have to do anything here right now. Now we are at these positions which holds the value 2. So we have to replace the element in the index number 2 with negative. So 7 will become minus 7. Now we are at element 3. So we have to make the index number 3 negative. So 7 will become minus 7. Now we are at this element 4. So we have to make the index position of element 4 negative. So 2 will become minus 2. Now we are at this minus 5. So absolute value of minus 5 will be 5. So here we have to make the element presented in the 5th index negative. So it will become -3. Now we found another one here. So we have to make the element negative which present in the 1 index. So there is already -1. We don't have to do anything right now. Again, we have found 1. So we have to make the element presented at 1 index -1. So it is already negative. So we don't have to do anything here. Till now, we have completed the iteration and we have seen that our original array becomes something like this. So here, the original array was given this, and now we have manipulated the array in this manner. So here we have seen that some of the element has the negative sign. So the intuition is if some of the element has the negative sign, that means those element is presented in the original array. Now we have to run a loop from left to right. And suppose the loop starts from this index position 1 because we have to get the positive integers which is missing. Now we have to run a loop from left to right and we have to check the first value which is non-negative. So here we have clearly seen that the first value which is non-negative is 4. And what is the index position of this element 4? It is 6. So here we can see that the element 6 is the first positive integer which is missing in the given input. I hope you understood the algorithm. Now one more thing. If all of the value is presented or all of the value is negative from 1 to n, then the answer will be n plus 1. Because suppose array has 1, 2, and 3, then here all of the element is present. So here the output will be 4. The 4 will be the size of array plus 1. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named find positive, missing positive, which is a parameter array. Now, we have to firstly check whether 1 is presented in the array or not. If 1 is not presented in the array, that means the first missing integer will be 1. So here we will run a loop from 0 to n and we will check whether the value is 1 or not. If it is, that means we have to make the flag of the is 1 found true. Now again, if our current element is less than is equal to 0 or greater than n, that means we have to replace the corresponding element with 1. And now if 1 is not found, that means we have to return 1. Again, we have to push the 1 into the vector. Now we have to run a loop from left to right again. And each time we have to take the absolute value and we will check whether the corresponding index has the positive sign or not. If it has the positive sign, that means we will have to make it negative. Now again, we have to run a loop from 1 to n. And if any of the element has sign positive or is greater than 0, that means those index number element is absent on the given input. That's why we have to return I. Otherwise, we have to return n plus 1. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we have to iterate each of the element from left to right. And the space complexity is big O of 1 because we are using only constant extra spaces to solve this problem. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.